here. Aloha, Richard Halverson here, and this is ITS128. And today, with this video, I'm going to cover the 5 programming projects at the end of Chapter 4. So I have the assignment page up here, and so I'm going to start here with this Chapter 4 programming project. While that's getting going, I'm going to do a CMD and get a command line, and I want to save. Let's see. I have this test.py program on my desktop from the previous video, and so if we look at the properties of the desktop, it is at this path. And so here in my command line, I have to do cd paste to get to that path. And then I can execute this. This is my test.py. I don't have anything in here. Print hello chapter 4 projects. And save that. And if I run it, Python test.py, it says hello chapter 4 projects. Okay, so we are ready to go there. All right, so the first project is to this is a compute the area of an n-sided polygon. So you're given the number of sides and you're given the length, okay? And this is a regular polygon, which means that all the sides, the length of all the sides are the same, and the angles also are all the same. And so this is the formula. And so we're going to use that formula. Let's just start by copying this formula. I'm going to put that right here. I'm going to replace this. I'm just going to do a paste. And so this is the formula. Let me put this down a little bit. And so I'm going to have to get n is the number of sides. So n equals, and that's an integer, input, enter the number of sides. Let me just copy it directly from here. Enter the number of sides. And we want, and what is this? Enter the side, which is enter the length, but I'm going to do it exactly the way it says here because I want to make sure I get all the points. Enter the side, and this is going to be S, and this is going to be a float, so you can have a decimal point. And then I'm going to do this calculation here, which is, this looks good, n times s to the second power is actually just s times s. I'll just put s times s. And divided by 4 times the tangent of pi, and it looks like we need another closing parentheses. And so what's tangent and what's pi? Well, we're going to be using, let's search, we're going to use the math module, the Python math module. So if we search for the Python math methods, or press enter, and we get, we click here, the first one is fine, and we read about the math module, which is what we want, and this is it. So we want to do like, put that in there, and then we're able to use these functions. What functions? Square root, for example, and all these, ceiling, absolute value, and we're going to want to use tangent. We're going to want to use tangent, and we're also going to want to use pi. Okay, so these are methods, and this is just a constant. Okay, and so these have parentheses. These will have a parentheses and an argument, and pi doesn't. So we're talking about, first of all, we've got to put input math to make sure we have the module. And then we want to do, this is going to be math dot tangent, and this is going to be, it's a lowercase math dot pi. Okay, and then after that, we're just going to, the area of the polygon is, we can just print the area of the polygon is, comma, area. All right, let's try to run this. Upward arrow, enter. Oop. Oh, it's not inputting. How do I do this again? Import math. See, it's a good thing we do it over here, because then we don't waste a use or a chance, although you get as many as you want. Okay, enter the number of sides. And what are we entering here? Let's go back to here and put this up here. Enter 5 sides, and 6.5 length per side, and we get 72, 6901, 6901, 7017, 4883, 85. Okay, looks good. All right, what's next? And let's go to the next project. Let's see, for this one, we are going to input A, B, C, D, or F, and it can be uppercase or lowercase, and it's going to display out the corresponding grade value. So we enter capital B. It says the numeric value for capital B is 3. If we enter a lowercase b, the numeric value for a lowercase grade lowercase b is 3. If we enter a T, T is an invalid grade. Okay, so this tells us pretty much everything we need to know. So I would say that it is something like, we don't need this. We need, get rid of that. Enter a letter grade. Enter a letter grade. And, oh, that's all we got to enter. All right, so this is going to be enter a letter grade, so we don't need to do any kind of thing. Let's just call it grade. And we don't need that. And it looks like we're just going to go right into an if statement here. If grade dot, and we want to preserve this because we need to write it back out again, but let's make it easier on ourselves and force it to be lower and look at the lower version of it. And if that's equal to a lowercase a, colon, enter, then we're going to print the numeric, easy, the numeric value for grade, the numeric value for grade, comma, grade, oops, end quote, comma, grade, comma, is 3. Oh, we just do that, okay. Is, for A, it's 4, quote, end quote. Okay, and then I'm just going to copy this and do an enter and do elif, L paste. Elif grade lower is B. Then the numeric value for that grade is 3. And let's just run this. I'm going to see what this looks like. See if it's working. Yes, so I saved it. Look back here. Upward arrow. Enter the letter grade. A. Numeric value is 4. Run it again. Capital B. Numeric value is 3. run it again, C, nothing. Didn't do anything. Okay, well, it's because nothing else is there. So let's do some more of these. This is B. Let's go this way. C, D, F. Oops, too many. Okay, B, C, D, F. And this can be else. Print that is an invalid grade. Okay, and so this is numeric value is 0, D is 1, C is 2, D is 3, 4. All right, that looks pretty good. Let's see what this looks like. Got it. C, okay, run it again. D, okay, run it again. Capital E, oh yeah, run it again. Capital F, okay, run it again. T, okay. All right, that looks good. You can take it from there. What's next? Let's see. Okay, here we're gonna enter the year and the first 3 letters of the month, and the first letter's got to be able to be uppercase and not lowercase. And we're just gonna print out the number of days. So, and if you do something like this, it's gonna say it's not correct. All right, so I don't think I'm gonna do all this one for you, but I'll certainly get you started here. We're gonna first need to enter a year. Please enter a year. And this can be an integer. And this can be called year. And we need to also enter a month. So we're going to enter a month. Oh, but this is going to be a string. Enter a month. And let's see. So we want to have if something like, I'm going to go like this. If month equals, okay, so let's do all of the January. January's 31 days, so let's do all the 31 days ones first. If month is equal to Jan, that's a 31 day, or month is equal to March, MAR, that's a 31 day, or month is equal to March, April, May. I'm going to let you do the rest of it. If that's true, then I'm going to print month, year has, comma, has 31 days. Okay, so you can finish this. There's more days, more months. And the next one is going to be, let's do, okay, I'm going to do February. Okay, I'll help you with that. Okay, I'll help you. If month is equal to Feb, then you're going to have then you got to look at the year. And if the year mod 4 is equal to 0, then it has 29 days. Otherwise, it has 28 days. So if the year mod 4 is equal to 0, then it has 29 days. Otherwise, it has 28 days. So the year 1999 has 28, 1998 has 28, 2000 has 29, 2001 has 28, 2002 has, and so on. It's not always true because at the century mark, it's different, except for, anyway. For February, we're going to print month, year. Oh, no, we need to see what year is. So if year mod 4 is equal to 0, colon, then print month, year has 29 days. Else, colon, print month, year has 28 days. Okay. Otherwise, month is an incorrect month name. Is an incorrect month name. All right. So now this is not complete because it does not have the months that have 30 days. It does not have even all the months that have 31 days. But I think we have taken care of February. So let's see what this looks like. I'm going to save it. I'm going to run it. And if I enter in 2000 and I enter in Feb, capital F, oops, try this again. 2000 and Feb, F-E-B, it says Feb 2000 has 29 days. How about 2001 Feb, 28 days? How about January, oops, the year is 2019, January is 31 days. But if we do something like April, no, year is 2019, April, APR is an incorrect month name. Well, the reason it said that is because we don't have it anywhere. It's not January or February or March or May. So it's going to say it was an incorrect month name. So you have to complete this. Fill that in to make it cover all the months. All right, what's next? Number 3. We just did this one. Number 4. Okay, this is the checksum. This is the ISBN checksum one. This is kind of cool. You learn about checksum. You learn all kinds of stuff in this class, and I do too. I mean, I knew about this stuff, but I didn't know this exactly. And I've never written any little programs to do these functions. So that's interesting to me. All right, so we're talking about ISBN 10 numbers. And if you know what an ISBN number is, it's just the number of like a book or something that's categorized, or it's given like a serial number, all the books and stuff. And there's a checksum at the end of it. So it's 9 digits, plus, and then a checksum is added at the end of it. So for this one, the checksum is a 1. So that's what it looks like this. For this one, the checksum is a X. So it looks like this. Turns out what the checksum is, you compute it with this expression, this formula. These are the digits of the ISBN number, the first 9 digits, which is what that is. And then digit 10, the last digit, is this. And what this is this is some big old number. You multiply it by this formula here, mod 11. Mod 11 is going to give you a result between 0 and 10, including 10. So what this says is that if it's 0 through 9, it's just what that is. But if it's 10, then you put an X. So we have to write a program that asks what the first 9 digits are, and then it's going to display out the 10-digit one, and it's going to have the checksum attached to the end of it. So they give us some tests here. This is a ISBN number, but it doesn't have enough digits, so you prints out an error message, or you enter in the 9 digits, and it just prints the 9 out plus the checksum. Inputs 9 digits, prints the 9 out with the checksum. All right, so let's do this program. First of all, I'm going to let's copy. I'm going to copy all this over just to have it there, and I'm also going to copy over this formula. Copy. So this is the formula here. And so I'm going to need an input, and I'm going to call it ISBN equals input. Enter the first. Do that. Okay. So that's the ISBN, and then it's going to do something like it's going to print out this. Okay. So anyway, so that's that. You're going to get the ISBN number, and then we have to go through each digit one by one like this. Okay. Well, this is a this is a 9-character string, and I want the first character to go there, but as an integer, not as a character. It's going to be a digit character, but I want the actual integer there. So, really, I can. I'm going to put this here just so I have it this way. So I'm going to say checksum equals this, and this first one is going to be ISBN, and I want the first character, and that would be the first character, 0:1. But I want an integer. I think I can do int. Yeah, I think so. Python string methods. Can I do int? Here. Returns integer from a number or string. Okay, so good. This is the one I want. So that is the function. It's just like that. Okay, yeah, right. You can even put a base. Ooh. Put a base, huh? Well, okay, anyway. Okay, so anyway, it's int. Int is what I want. So int, and so that times 1 plus int of ISBN 1:2 is that, and let's see. Okay, so after I figure out all that, I'm gonna do if checksum equals 10, then print the ISBN 10 number is, and comma, ISBN plus quote, capital X, quote. Right? That looks like that. I gotta check to make sure this is 9 digits. If how do you count out the number of length of a string? Python string length len. Oh, it's just len. Okay. If len ISBN equals 9, which is what we want, then do all this stuff. All right. So first do the checksum. Figure that out. If checksum is equal to 10, then print that out. Otherwise, else colon print colon the ISBN-10 number is quote comma ISBN plus string. This is going to convert it to a string checksum. Okay, that should do that. If else, so this is an else to the if the length of the ISBN number is equal to 9. If it's not equal to 9, I want to print out print. I want to print incorrect input. It must have 9 digits. Okay, I don't need this anymore. I don't think I need any of this anymore. And I got to finish this. I'm going to do slash enter 1, 2, 3. I'm going to do another one about right here. Slash enter. Okay, and so this was D2, and I'm going to make this one D3, and this is going to be D4, and this is going to be D5, and this is going to be D6, and this is going to be D7, D8, and D9. But D9, okay, D1, D2 is that. D3 is 2 colon 3. 4 is 3 colon 4. 5 is 4 colon 5. 6 is 5 colon 6. 7 is 6 colon 7. 8 is 7 colon 8. And 9 is 8 colon 9. Mod 11. Okay, now what I'm going to do first, just to make sure I know what I'm doing, I'm going to do this print first digit is quote comma ISBN. I'm going to do this. Yeah, I already see I made a mistake here. I'm going to see, the first digit is 0, comma 1. And I'm gonna just do this just to first second, third, last. 0, 1, 1, 2, 2, 3, 8, 9. Because I just want to make sure that's right. And then I'll take that out so I know what I'm doing. Okay, and then this, I made a mistake here. I need to close the parentheses on all these ones here. I do that a lot. Close the parentheses on my functions. Okay, so that should be good. So if the length, it reads an ISBN. If the length is equal to 9, then it computes this checksum. Otherwise, and then it checks to see if the checksum is equal to 10. If it's 10, it just has to stick an X on the end of it. Otherwise, it's going to be 0 through 9. And if it's 0 through 9, it's going to stick the 0 through 9 at the end of it. But 0 through 9 is going to be a digit. And so we have to convert the digit into a string and attach that onto the end of the ISBN number. And this is the sentence that's output if it's not 9 digits. All right. So I'm going to save this and I'm going to see what this looks like first. Let me just run it. There's a syntax error, and that is something doesn't like something about this end parentheses. So let's see what's going on. Ooh, too many here. Yeah, it's okay. Let's see if that works. Okay, I'm gonna do 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got the 1, the 2, the 3, and the 9, and I guess it must be X. I'm gonna do one of these other ones here. We go here, and here, and let me try. Let me try 0, 1, 3, 6, 0, 12, 67. So it's exactly this. And if I go enter, it says it puts on a 1, and that's exactly what it put on. Okay, great. Let me get rid of these. I don't need these anymore. And let me check this other one. Let me save this. The other one is this one, 0, 1, 2. I'm going to work if I copy that. And I do upward arrow this. And what happens if I paste it? Ooh. All right. Does the X. Just like that. All right. That looks good. Take it. You can take it from there. And the last one here is you input a hex digit and it displays its corresponding binary number. So, and it looks like it's case insensitive. So like, for example, if you enter in the hex digit of capital B, it displays out the binary value. And if you do lowercase b, it also does the same thing. And it rejects a non-binary digit. Okay, so we need to read in the binary digits. So it's going to be something like enter a hex digit. Enter a hex digit, and we say the binary value is. And then we do some calculations, and we print the binary value is. Okay, so we input this hex digit, and if the hex digit lower equals a 0. Yeah, we have to look at every single one of them because we have to do the translation from hex to binary. So if it's 0, then, oh, you need the colon. Then print, oh, this. The binary value, yeah, we got to do the whole thing here, is 0, 0, 0, 0, close quote. This should be elif hex dot lower. No, I don't need the dot lower here, do I? Hex equals 1. 1. Then print the binary value is 0, 0, 0, 1. And let me do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 is going to be, A is going to be different. So now we got to do the lower. And we can do A is 10, 10. And B, C, D, E, F. F, E, E, D, C, B, A, 9, 8, 7, 6, 5, 4, 3, 2, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and 1, 1, 1, 1. All right. No, incorrect. Oh, invalid input. Invalid input. All right. Let's save this and give it a shot. A. That looks good. Capital A. 0. 3. 6. Oops. 6. F. Oops. F. G. Invalid. Okay. Anyway, so that's pretty good. And I think that is the end of our programming projects. So I hope that helped out, and I hope you're able to finish up all the programming projects and finish this up. And next week we will start chapter 5. So thanks for watching.